Welcome back to another lesson of C++ and C programming style with Wehbe. This clip focuses on pointer compiler errors. Let's start with instar is not int. So often we get the problem that people point an instar to an int value instead of an int value's address. So what do I mean by that? Well, when I run this right now, I have pointer instar as p1, an integer g that is equal to 2. So in this first case here, if I were to take p1 and then just make it equal to g, in this case I would get an instar being converted between an int. So in this case, p1 being an int pointer should point to the address of g. So editing this out and commenting this line in, we will see that this fixes the problem, and we actually get the memory address of where G2 is stored, right? However, I do want to point out an interesting caveat. Sometimes people think that this, creating a star P1 to G, will actually fix the problem, but you actually get a runtime error, and this shows here P1 is equal to 0. Right now, this means that we're not getting a memory address. Why? Because P1 is actually considered uninitialized in this function. So again, be careful to point at only initialized variables. Next common type of error that we see is type mismatch. Here you can see that I have an integer g and a float pointer p1. When I run this code, it'll tell me it cannot convert instar to float star in assignment. What that really means is that we're having an issue here of type. The types do not match. So how do we fix this? Well, we cannot use a float pointer to an integer. We should use an integer pointer to the address of an integer. So here, now when we run this, we get the correct showing of a memory address for our integer g. The type of errors that I tend to get the most questions about are memory errors when using pointers and allocating memory on the heap. The most common type of errors that we get when we are using pointers is when we start to move from using just the stack memory to also using the heap memory. In C++, we have to allocate our own memory. So let's start simple. Let's make a single pointer, an instar p, initializing it, and then we can make p equal to the address of r. So here we see this is a normal pointer situation. We should not be getting any errors right now. And we can see normal termination, unused variables, of course, as a warning. But here's something that students tend to do. They tend to get mixed up and try and free everything. So they try to free pointer p. And here we get an error. Because although it says, it's just a warning, you're trying to attempt to free a non-heap object, right? So here, it's actually not the correct way to use free. You should only use free if you've actually malloced space. The next thing that we see people doing is trying to free the same pointer twice. So let's say that I had a much longer program. I may have forgotten that I've already freed my pointer p and try and feed again. So when I run this again, I get an execution, but I see that again I'm attempting to free a non-heap object. So that being said, how do we allocate memory onto the heap? Well, Malloc is actually how we would do it. So first thing we need to do is we have our initialized pointer. We're going to first tell it what kind of pointer it's going to be. So it's going to be an instar pointer in this case because we are working with integers. And we are going to malloc whatever size we need. So commonly we might see people malloc some number of space, oftentimes a really huge number. Now, although this works in our case, it's definitely a messy way of mallocing space. Also, in this case here, we actually get to the end of the program before freeing. This is what we'd call a memory leak. So, at all cases, we need to free whatever we malloc. In order to properly use malloc, it's suggested to use the sizeof function. Now, within the sizeof function, you want to be mallocing the size of, in this case, let's say an int. Because we might have more than a single int, we can actually multiply the size of the int by the number of ints. So for example, if we were making an array, and our array was going to start at 0, go to 3, and have a size of 4, then our array length would be multiplied by the size of int. So here I simulate this using times n. So here, when we run it, we're not going to actually find that there is too many errors from the compiler. Why? Because generally when we're looking at memory errors, we want to use something like Valgrind to detect memory leaks. Another common problem, aside from forgetting to free at all, is that people will actually call the pointer after it's been freed. So we've already freed p here, but here I have p going to be the address of n, let's say. So again, here we're not going to see that error, but we know that it is an error because p is free. Again, that's because this simpler compiler here is not giving us all the information we need. Finally, remember that malloc and free are C-style coding solutions, whereas in C++ style, you have new and delete. Do not cross over. So for example, do not use new and free together.